Hello everyone. There is another very interesting problem. So there is a car which is moving away with a speed of v from a long wall, and it's moving at an angle of alpha to it. At the moment when the distance to the wall is equal to L, the driver gives a short sound signal. The question asks how far will the car travel before the driver hears the echo. The speed of sound in air is given as c. So this is a very interesting problem. So as you can see from this picture, a car is moving on a straight line away from the wall, angle alpha, and then when the distance is L, it makes a short signal, so that the sound of the signal will travel everywhere and it will bounce off from the wall, and the driver should be able to hear his own echo after traveling some distance. And the question asks what distance it will travel before it hears the echo. This problem can be solved very easily if we just utilize the idea of a symmetry. Okay, the car will be moving away from the wall. Let's say that at this point it makes the beep sound, and after some time will be, so initially it was at point A, but now it will be at point B. Sound is propagating everywhere, but only one specific one that hits the wall and reflects will be heard again at point B. So, and then the question is what distance of x will the car travel before it hears his own echo. So this problem can be solved easily if we utilize the idea of a symmetry and the reflection. If you look carefully, what we can do is imagine that the wall is actually like a huge mirror. The reflection of the car in the mirror is also moving at speed v this way. So this distance will be L here. And then the reflection that the sound makes from the wall can be viewed like this. So you see, it's actually this sound that propagates in the real world and that reflects from the wall and reaches the car. But if we just imagine that the car inside the wall, the imaginary car, the reflection makes same beeping sound and makes same sort of reflection. Here we can just make very simple triangle. If we look at this triangle, a larger triangle, we see that this whole distance traveled by the sound is same as the red arrows in the real world that hitting the wall and the bouncing off the wall. So this will be c times t, speed of sound times t. If we look closely, the speed of the car can be decomposed into two components. The one that's going away from the wall, which is a v times sine alpha, and the one that's going along the wall, v times cosine alpha, where alpha is here, right? The distance that the car travels along the wall would be v cosine alpha times t, and then the distance that it travels away from the wall would be v sine alpha times t, right? And this distance here is c times t, and then from this we can make one very simple equation just by using Pythagorean theorem. So the equation goes like this. So if you remember that if we have this kind of a triangle, if there's a A, B, and the C, then A square plus B square equals to C square. Don't be confusing the C with my C. This is just to remind you about the Pythagorean theorem. So it's just a side note. Okay. When it comes to our case, so we have to write our own equation. So it goes like this. The hypotenuse, which is c times t squared, equals to the long edge is 2l plus v sine alpha times t squared plus v cosine alpha times t squared. So this is the most important equation. So once you draw this kind of nice picture and you write the Pythagorean theorem, the rest is just some basic algebra. Of course, we will get a quadratic equation that we have to solve it, and quadratic equation will give us two solutions, and we have to wisely choose only one of them. So if we expand this equation, so we will get c squared t squared 4l squared plus v squared sine squared alpha t squared plus 4l v sine alpha t plus v squared cosine squared alpha t squared. And you see that there's a v times sine squared alpha and the v cosine squared alpha. We can combine them. So we know that this one here is actually equals to 1, right? So that simplifies our life. C squared t squared equals to 4l squared plus 4l v sine alpha t plus v squared t squared. So let's write down the quadratic equation as minus t squared c squared minus v squared plus 4l v sine alpha times t plus 4l squared equals 0. So this is our quadratic equation in terms of t squared. So we have to find the t. T is the time until the driver hears his own echo. By using the solution for quadratic equation, we get minus 4l v sine alpha plus minus 16 l square v square sine square alpha plus 4 c square minus v square times 4l squared, everything under the square root, divided by minus 2 c squared minus v squared. So this can definitely be simplified. So minus 4l v sine alpha plus or minus. So we see that 16 l squared can be taken out of the square root, so it will be 4l. Eventually we'll get, and here we can just use the fact that sine square alpha minus 1 equals to negative cosine square alpha. So using that, we can get the t. Okay, so here's the problem. So we have two solutions, one with plus sign, the other one with minus sign. And which one do we use? In case if car doesn't move at all, in our problem we stated that the car is moving at a speed of v away from the wall at an angle of alpha. If the speed of the car will be 0, the sound will bounce off the wall and come back to him. It will definitely take some time. So I guess the time is supposed to be 2l divided by c, right? So it goes a distance l to the wall and comes back. And then this time it is reasonable, right? It has to be positive. So in case if v is 0, our equation takes the following value. We see that if we use a negative sign here, everything starts to make sense because we will eventually get 2l over c, which is exactly what we get. It turns out that so we should not have two different solutions. We should have only one solution, and the one with the negative sign in front of the square root. Okay, so the time eventually becomes, so all the negatives can go away, and then we can simplify our problem by dividing by 2. So eventually we will get, so this is the time, and the time passes until the driver hears the echo. The distance traveled is very easy. It's just the velocity times t. So it's exactly the same as above. It's just the velocity multiplied to lv. So this is our final result for the distance. So again, the problem might look a little bit challenging, and everything comes down to the point of drawing a nice picture and then utilizing the symmetry in this case. So once you get that idea, the rest of the problem is very easy and just algebraic manipulation. And the important point is, when you get to the point where you have two different solutions, try to analyze and see if both of them make sense, or if you need to pick only one. In this case, I showed that in case when the speed of the car is 0, the beeping sound should just travel towards the wall and come back at a time of 2L over C, and this helped me to choose which sign I need to choose, whether it's a positive or negative. If I choose the positive one, I will get a negative sign in front, and it doesn't make sense, the negative time. So this is the result. Please let me know if you find this problem interesting, and please subscribe to my channel. Thank you very much for your attention.